Okay, let us start with question number one. The question number one is about Venn diagram. This question says that look at the diagram and try to identify that the shaded area is which one of these 5 options. Now, if you look at the shaded area, it is actually what? Let's highlight one by one. I will make the diagrams for all 5 options and try to see which one matches the one that is given in the question. So let me start with option E. For option E here, suppose this is my space and I have A1, E1, E2, and E3. What does option E say? E1 union E2 whole complement. First, I will highlight E1 union E2 whole complement. In every diagram, assume that the top left is E1, the top right is E2, and the bottom is E3. I will not give the notation in everything. E1 union E2 whole complement. What is that? Everything outside these two. So I will highlight E1 union E2 whole complement, everything outside E1 union E2. Take this chair. Come here. Yeah, this one. Put the bag down there on the floor. Charger on the floor. Again. 2 chairs this time. But this time we stole one, so we took one back. If you write a request, we can. I have no objection.
The doctor. Yeah. He doesn't have a third class. The class there is big.
For me, I have no objection if you change the class, location, anything. Write an application to registrar and I will write, I don't have objection. Give it to me. I will process it through math chairman office. Now, union E3. Where is E3? I will highlight E3 with the green color, or let's say this is E3. Union means all what is highlighted. Does this match the diagram? No. So E option is not correct. This is E. Let me make D. This is D. D says E1 intersection E2. I will highlight with the yellow color. This is E1 intersection E2. Then intersection E3. I will highlight E3 with the blue color and intersection will become green. So in this D part, green area is actually D part. Does this green area match the one in the diagram? No. Let's make part C. E1 union E2 again. So E1 union, no. Union E2 inside. E1 union E2. This is E1 union E2. Then intersection with what? Intersection with E3, I will highlight the E3 and the intersection will become green. The green part, does it match with the gray part? No. Then comes B part. B says E1 union E2 again, E1 union E2. And then union with E3. So I will highlight E3 and the whole thing, green, blue, yellow, all of it is part B. Does this match with? No. Finally, part A here. E1 intersection E2 with yellow color first. E1 intersection E2. Then it's union with E3. So I will highlight E3 with blue color, and union means that all the 3 colors, yellow, blue, and green. Does this match with the diagram given? Yes. So this is how you are supposed to recognize what is given. Yes. No. I'm just explaining if in exam you get a different question out of these 5 options, how to visually see. Visually, it's very clear right away that what is highlighted. But if you have practice of doing the events from the Venn diagram, you will be able to do it in 1 second visually. You don't need to do all of it. I am showing you why the other 4 options are wrong. Okay. No, there is no direct. Let us move on towards question number 2. The question number 2 says that an injection molded part is equally likely to be obtained from any one of the 10 cavities on the mold. What is the probability that the part is obtained not from cavity 7, not from cavity 8? So let me first make the sample space. It can be obtained from cavity 1, from 2, from 3, or from 10. Clear? From any of these cavities. Event A is that part is not from 7 nor 8. What is A? 9, 10. What is the probability? Yes, what is the probability of A? 8/10. Or you can use the complement rule. First, find the probability of the complement. A complement is what? Part is from 8, 7, and or 8. So what is the probability of A? 2/10. So find the probability of the complement and then find 1 minus probability of A complement. Question 3. The analysis of the results from a leaf transformation experiment, turning a leaf into a petal, is summarized by the type of transformation completed. So there are 2 types of transformations they are applying, the textural transformation and the color transformation. Okay. If you get this kind of question in exam, always the first thing you should do is complete the table, as we did in the slides. Complete the table. For this table, what is missing? Sums are missing. So what is the sum of the second column? 50. What is the sum of first column? 232 plus 8 is 240, 250. 250. What is the sum of first, second, 250? This means 300 is the total sum. 18 plus 10, 28. 300 minus 28. 272? Yes. So we complete the table. Once we complete the table, if a leaf completes the color transformation, what is the probability? What is the probability that it will complete the textural transformation? Complete textural given complete color. Read the question one more time and see how from the question I wrote this. Most important part. Reading the question and getting to know what is required. Once you have this one, it's just the implementation of the formula from the formula sheet. So that should not be a trouble. Here, if a leaf completes the color transformation, that means this is the given information. They are telling you this has already happened. So the leaf has already completed the color transformation. Now, what is the probability that it will complete the textual transformation also? So remember one thing, for any conditional probability question, there will be 2 statements. One statement will be given to you, one statement will be asked to you. The given statement always comes after the given, and asked statement always comes before the given. So remember this rule for any conditional probability question. Whatever is required comes first, whatever is given comes after the given sign. Okay. Now call this one to be your event A. Let's say this one to be your event A and this one to be your event B. Okay, just give it name. So you are required to find probability of A given B. What is the formula? This is the formula, correct? Now, what is the probability of A intersection B? Is N of A intersection B over N of S over what is probability of B? It is N of B over N of S, correct? Now, how many leaves in your sample space of 300 are there where they completed the textural transformation and they completed the color transformation? Completed textural and completed by N of S is 300. B even says that they completed the color transformation. So how many of them they completed the color transformation? Yes. 272. So this is 272 by 300. So this one rounds to 0.8529. There? Any question? I use the formula, not the revised sample space. You can use revised sample space. Yes. Here, yes, both are applicable. Question 4. The probability that a lab specimen contains high level of contamination is 0.15. A lab specimen contains high level of contamination is 0.15. So let me, whatever is highlighted, I will call it event A. That a lab specimen contains high level of contamination. This is event A. Okay, and the probability of A is given to me as 0.15. Okay, then 4 samples are checked and the samples are independent. What is the probability that at least one contains high level of contamination? At least one means what? One contains, or two contains, or three contain, or four contain. So this question, if you solve it in true spirit, it will be too long. There are too many cases. One containing means that maybe the first one, maybe the second one, maybe the third one, maybe the fourth one. 4 cases inside one. Then two, which two? Maybe first and second, maybe first and third, maybe first and fourth, maybe second and third, maybe second and fourth, maybe third and fourth. Too many cases to solve. You must think of a complement rule in this case to solve the opposite of this event and then take 1 minus probability of that opposite. So think of an opposite event of this event. Call this one to be event B. This one to be event B, that at least one sample contains high contamination. What is B complement? No sample contains so you can say probability of B is actually 1 minus probability of B complement, which is 1 minus. What is the probability that no sample contains high contamination? That is probability of the first sample does not contain contamination. The second sample does not. Let me first write it as a whole. The first one does not contain, the second one does not contain, the third one does not contain, the fourth one does not contain, right? Then there is something additional given in the question. What does that say? The samples are independent. What is the multiplication rule for independent events? For two independent events, what is probability of A intersection B? A multiplied by B. For 3 events, A multiplied by B multiplied by C. For 4 events, so use that independence and say it is 1 minus A1 complement, A2 complement, A3 complement, A4 complement. So that is 1 minus. What is the probability that a sample does not contain high contamination? What is the probability that a sample contains high contamination? 0.15. What is the probability it doesn't contain high contamination? 0.85 times 0.85 times 0.85 times 0.85, which is 1 minus 0.85 to the power 4. And this simplifies to 0.478. Any questions?
Explain this step.
Second step where? Here?
Probability of B, 1 minus B.
We studied the complement rule, that probability of B complement is 1 minus probability of B.
No, yeah, I understand that, but how did we get the probability of A complement B? A.
What is B complement? That out of the 4 samples, no sample contains high contamination. This is equivalent to saying that sample 1 does not contain high contamination, and sample 2 does not contain high contamination, and sample 3 does not contain high contamination, and sample 4 does not contain high contamination. This is what I wrote here. This is that no sample contains high contamination. This one says sample 1 does not contain high contamination, and sample 2, and sample 3, and sample 4 does not contain high contamination. Express the bigger event into small events where we are given the probabilities. Yes, after that, because they are independent, we express them like this one, the product. Any more questions? Let's move on. An inspector working for a manufacturing company has a 99% chance of correctly identifying defective item. What is this given? If you understand what is this given, you can easily solve the question here up to this point. What is this given? Inside this statement, there are actually 2 things. One thing is that the item is defective, actually defective. And the other thing is that the inspector says it is defective. These are 2 different things. 2 different things. For example, a student is cheating in the exam. And second thing, the proctor is saying that he's cheating in the exam. These are 2 different things. Maybe he was cheating and I'm lying. Maybe he is not cheating and I'm saying the truth. These are 2 different things. So one of the things here is that the object is actually defective. And the second thing is that the inspector declares it to be defective. So we need to understand these 2 things. Let me call these 2 to be different events. Event A, that item is actually defective. And event B, that inspector declares the item defective. You know, true positive, false positive, true negative, false negative. It's kind of that story. Now let's read what is given, by the way, 0.99. What is it? In terms of A and B. Now I have defined the events to you. In terms of A and B, what probability is that given in the yellow line? Probability of B, that the inspector declares the item to be defective. Inspector may declare a good item to be defective. Inspector might be wrong. Now read the statement again. Correctly identifying, not incorrectly. Inspector may identify incorrectly. When you are saying that the probability of B, that means correctly or incorrectly, inspector saying it is defective. That's unconditional probability of B. It's not the one that is given here in the yellow line. What is given in the yellow line? It is the probability that the inspector says that the item is defective, given the item was actually defective. correctly identifying the item as defective. Take 1 minute and try to digest what I wrote in terms of A and B. This is what is given in the yellow line. An inspector working for a manufacturing company has a 99% chance of correctly identifying a defective item. Means that the item was defective and the inspector identified it as defective. So the item was defective, and given the item was defective, the inspector identified it as defective. This probability is 0.99. Read the second part now. I will highlight this one with the yellow color. Now the second part of the statement, and what? Incorrectly classifying a good item as a defective. What is this given? Inspector says what? Inspector says it is defective, but actually the item is, it is good. So what's given here is probability that the inspector says it is defective, given it was not defective. Now let's read the question. The company has evidence that 2% of its items are actually defective. What is this given? This is unconditional probability of A. What is the probability that you select any item and it will be defective? 0.02. Let me highlight with the same color. This is all given information you have, okay, from the question. Now, the next tough thing to read and try to see what is required. What is the probability that item is selected and classified as defective? Classified as defective, yes. B, inspector says it is defective, classified as defective. Simple unconditional probability of B is required. What rule will you use here? I will make a diagram for you. And mostly this is a question from the total probability theorem. Mostly the questions from the total probability theorem will be belonging to two events. I showed you in slides 3 events, I think 4 events, Dammam, Riyadh, Qasim, and 4 regions, right? Here there are only 2 regions. So let me make a diagram for you. Suppose this is your company, whole company, all the products. Okay. Some of these products are defective, some of these products are not defective. So let me say don't go at the magnitude because I have to write too many things inside. I'm making this big, but this is 2%. This is 98%. Then, yes. I think that should be A and B. A and A complement, yes. Then, here is the inside the circle, the inspector is saying it is defective. Outside the circle, inspector is saying non-defective. What is this event? B. This is B. Okay. B is a sum of 2 parts. Can you see those 2 parts? Yes. What is the first part? It is a sum of 2 mutually exclusive parts, correct? So according to the total probability theorem, what is total probability of B? Is equal to this, correct? Now the first one, you can express it into conditional probabilities using 2 ways. One of them will be useful, one of them will be useless. Which one is useful? I can express it as probability of B into A given B or A into B given A. If I express it as B into A given B, what is required on the left side? I don't have B. So I will express it the first way, which is plus now you have everything to plug in. What is probability of A? 2%. What is B given A? What is A complement? 98, not given directly, but from A you can find A complement, which is 98%. If 2% are defective, 98% are non-defective. So this is 0.02 into 0.99 plus 0.98 into 0.005. This will simplify to 0.0247. Any question? This seems like A plus question. This seems like an A plus question. This is an application of total probability theorem, but only when the partitioning is into two pieces. If the partitioning was into more than two pieces, that's what we did in the class for 4 partitionings, the Mam, Riyadh, Qasim, and whatever, Makkah region. Let's move on. Now we move on to term 233, question 1. A part selected for a testing is equally likely to have been produced by one of the 6 cutting tools. What is the probability that the part is produced by either tool 3 or tool 5? Can there be a part which is made by two tools? No, there is no intersection. Minus no intersection. What is the probability that it is made by tool 3? Each tool is equally likely. And how many tools? 6 tools. Simple question. 2 by 6, 1 by 3, 0.3333. Again, a table question. Let's first find the sums. 8 plus 5, 13, 245 plus 250, 350, 7, 350, and 20, 370. The analysis of shaft for a compressor is summarized by conformance to specification. If a shaft is selected randomly, what is the probability that shaft conforms to surface finish or to roundness requirement? Let me call the surface finish. Shaft conforms to surface finish requirement. Let me call this one to be event A. And the shaft conforms to roundness requirements. Let me call this one to be event B. What is required? Read the statement and see what is required in terms of A and B. A or B, which is union.
Yeah. So basically 160.
I don't know about the final. Let me solve it. So apply the addition theorem. What is the probability of A that a shaft conforms to surface finish? Where is surface finish? Let me highlight it with the yellow color. Here it is. Can you see it? 350 divided by 370. What is the probability that a shaft conforms to roundness requirement? Where is roundness requirement? Minus, what is the intersection between the two of them? 300 and so sum it and get the answer. Same table. If a shaft is selected at random, what is the probability that shaft conforms to what is yellow? You called yellow one to be what event? You called it to be A, that the shaft conforms to surface finish requirement A. Then given what? It does not confirm the roundness requirement. B complement. Okay. Don't think complicated. Just apply first the conditional probability rule. Conditional probability of something given something is what? The intersection of the two somethings divided by the second something. The intersection of two somethings divided by the second something. Now think about more rules in the numerator. What is A intersection B complement? First think of the rule. The part of A excluding A intersection B. Think of rules for the denominator. Probability of a complement of an event. Now you are at the stage where you plug in the numbers, okay? First, try to apply all the rules and get to the most simplified expression. Finally, plug in the numbers. Let's plug in the numbers. What is probability of A? That the shaft conforms to surface finish. Minus, what is probability of A intersection B? It conforms to roundness and also to surface finish. Divided by 1 minus, what is the probability of B? That it conforms to roundness. So you simplify this one and it comes out to be 0.3846. Clear? A lot of 100 semiconductor chips contains 20 that are defective. Total how many? Total there are 100. There are 20 defectives and 80 non-defectives. 2 are selected without replacement from the lot. 2 are selected without replacement from the lot. What is the probability that both are defective? Probability both are defective. Can I write it as probability of D1 intersection D2? First one is defective and second one is defective. Is this same as both are defective?
Because we will take one and we
Yes, you will not replace it. Is this equivalent to just taking 2 together?
the probability of defect will decrease. This defective first one.
If I have 35 students in this class and I pick one and I don't replace back and then I pick another one to put them onto the stage, is this equivalent to picking 2 together? It is equivalent to picking two together. If I'm picking with replacement, then it is not picking equivalent. If I'm picking one and replacing it back and then picking the second, that's not equivalent to picking two together. But if I'm picking two together, that is equivalent to picking one by one without replacement, because I'm not replacing it back. Okay, so picking without replacement is equivalent to picking together. Okay, so that's why I'm saying probability both are defective is equivalent to probability that first is defective and second is defective. Now apply the multiplication rule for not independent events. What is this? If they were independent, just the product. Because they are not independent, not the product. Okay. What is the probability that you pick first and it is defective? 20 over 100. For this conditional probability, I said we have two methods of finding conditional probability. One is revised sample space method. The other one is formula method. If you use the formula method, this will open as probability of D1 intersection D2 over probability of D1, right? Can you use the formula here? Do you have these two?
D1 respect D2.
Don't have it, right? So the only way to move forward is revise sample space. Revise your sample space with respect to D1. That is, you picked first and the first one is defective. Now revise your sample space. How many left in your space? 19 over 99. Those of you who might have seen the counting technique somewhere, you can apply the counting technique here. But we did not cover the counting techniques in this course, okay? But this can be solved using the combination rules. Last question, circuit question. The probability that each of these four devices will work is given in the diagram. This device will let the current pass is 0.9. This device lets the current pass is 0.95 and so on. What is the probability that the current will pass through? Now, looking at the organization of this diagram, the current will only pass through if it passes through from here up to here and then from here up to here. Okay. What if the current reaches here, but one of these two does not allow, the current will not pass? What if one of these two does not allow, the current will not pass? So let me first break it down into simple questions. I will define this space to be A and this space to be B. And the current will only pass if it passes through A and B, not A or B. If it passes through A and it also passes through B, right? And the question says that each of the device is independent. Question says that each of the devices in so A intersection B will become what? A into B. Okay. Now let's break down. What is the probability that the current will pass through this portion? It might pass through this. It might pass through this. It might pass through both. So I'm saying it passes through this or this. What is that? What is the probability that the current passes through the second path? Also union. So what is probability of A1 union A2? And what is the probability of B1 union B2? Now, what is the probability that the current will pass through A1, the top one, the bottom one, from both? They are independent. So both intersection means product. Pass through the top right, bottom right, both on the right. And simplify this one, and this will give you the answer. There are 3 questions that I specified from your exercise, which are similar to this circuit. Solve those 3 questions and let me know. This is it from today's class. I will see you on Thursday with the new chapter, inshallah.